Well, hello there. This is KP the Math G once again. As always, loving to teach calculus material and other things, algebra 2 or, well, a little bit of geometry. But trigonometry and pre-calculus and AP calculus and maybe some college algebra if anybody wanted to do that, I'd do that as well. Well, we are talking about the chain rule and we're doing part 2. The reason we're doing 2 parts to this is that the first part was just kind of an introductory to the idea behind the chain rule. But now we're going to do like a combination of the chain and say maybe the product rule, or the chain rule and the quotient rule, and the chain rule and the power rule. And we really have to get this down. We have to nail this. I remember years ago when I was taking calculus 2, we dealt with this chain rule, and well, I didn't rule over it, I tell you, for a little while, and finally I started getting it together. And anyway, we just have to really pay close attention to this. I'm really looking forward to our next series of lessons. We're going to get into afterwards implicit differentiation, and then one of my favorites, related rates. But the chain rule is also one of my favorites. I love to teach the chain rule. Well, okay, without further ado, let's get started. And I have some examples here. Let's look at this chain rule in this regard here. Excuse me if I'm having a little trouble figuring out exactly where I'm at with this. Okay. Well, okay. Let's just review the chain rule just a little bit. Let's start with that. I had another example in mind, but we'll go ahead. It does not matter. If y is equal to, now this was probably from part 1. This would be kind of a continuation of part 1. So I just want to kind of get you re-familiar, if you're not already familiar with this, the chain rule. Now always you take the derivative of the outer part and not the inner part, and then you take a derivative of the inner part. And I hope that explained it. Okay, so y prime. Alright, the derivative of cosine is negative sine, alright, of all this stuff here. So 4x to the 6th plus 3x squared. Okay, now we take the derivative of 4x to the 6th plus 3x squared, and we're taking that means the derivative of, so that's what we're going to do next. Okay, so this equals, okay, 4x to the 6th plus 3x squared. Now this is the power rule on both of these. Alright, so 4 times 6 is 24. X to the 5th power, always take 1 away, and then plus 3 times 2 is 6. X to the 1st power, of course you don't need that 1, it's understood to be there. And really and truly, that's it. Now please, please, please do not, and I repeat not, make a mistake and try to distribute this with this. If you didn't have the negative sign there, that would be okay, but you have this. This is an argument here. This is just a polynomial here. so happens that a polynomial exists inside as part of the argument, but you do not multiply the argument times the polynomial. Oh, no, don't do that. Leave it alone. That is your final answer. As a matter of fact, it probably would not be a bad idea to just do this if you want to. 24x to the 5th plus 6x, and then sign, and put the sign and trail that. Oh, wow. 4x to the 6th plus 3x squared. Now, that's probably better. And if you wanted to distribute the negative over both of them, you could. It's okay. Either way is fine. Okay. I would like to do this one here, and I have another example. Let me see if I can find it real quick. If you don't have this book, please get it. AP Calculus AB lecture notes. I'm getting some of my problems from, although I do change the problems up slightly, okay, so it won't be exact. So that's how I do that. This is a very good book to go by, and it does take you through the order that you need to learn all of this. Let me get to that page. Just wanted to look at one example, and like I said, I don't use the exact same example that they do. All right, let's see. I'm getting to it. Bear with me. I apologize. I want to see the type problems that they had. Yeah, this is it right here. So let's look at this problem here. I'm going to go ahead and erase this part right here. All right. Okay. Go ahead and erase it. I know I can get to the other side of the board, but go ahead and erase this. I can make this fast. And again, I apologize for the delay. I knew that there was a different problem in mind that they had in mind, and I want to do that. It's going to take a little bit of doing because it's a combination of the chain rule and the product rule. So let's say that f at x is equal to, and I'm not using the exact same one, but it's kind of similar to it. Let's go with 5x to the 4th plus 3x squared. Okay, and let's do this. Let's literally bring this up to the 3rd power. Okay, and then times, let's do this again, 4x minus, now let's go 8, and let's raise this to the 4th power. Okay, now, something like that. Now, we still have to do the product rule, but incorporated in the product rule, we may need to do the chain rule. Alright, so we're going to call this the first, and then this the second. And remember that the chain rule is, generally speaking, I'm just going to put this off to the side, that, you know, f prime at x, well, whatever, I shouldn't do that, but the derivative of it is the first, if you want to, times the derivative of the second, plus the derivative of the first, if you want to do it that way, times the second, So, alright, so there we go. Alright, so this is the way we're going to do it. I mean, as long as you interchange and put a plus sign between it, you're okay. Alright, so let's go ahead and do this. The first, I'm just going to write this down, f prime at x. Alright, here's the first, 5x to the fourth plus 3x squared cubed. Haven't done anything with that. Now times the derivative of this one. But now we've got a combination of the power rule and the chain. So we're going to have to do this first. So times 4 times 4x minus 8. Do no derivative in here yet. We need to just bring this exponent down 1. So from 4 it's down to 3. And then down here we do the derivative of this, which the derivative of 4x minus 8 is just simply 4, because the derivative of 4x is 4. Remember, the derivative of a constant is 0. Alright, so that is the first times the derivative of the second. Alright, I don't know, let me erase this. I probably could have put it up somewhere else, but I'm just going to go ahead and expand that, or go a little further now. Now plus, now I do the derivative of this. Woo! Okay, so the derivative of this is going to be 3 times 5x to the fourth plus 3x squared. Remember, we're going to reduce the exponent by 1. So that's a 2 here. Alright. That's a 2. Now I want to do the derivative of these two. Alright, that's just the power rule. 5 times 4 is 20. 20x to the third power plus 3 times 2. 2 times 3 is 6. X to the 1, or just 6x. So that is your derivative of the, alright, so the first times the derivative of the second plus the derivative of the first. Okay, I'm going to do this right here, and then just times times the second. We're just going to put it down here somewhere. That's just 4x minus 8 raised to the fourth power. So there it is. We took the first times the derivative of the second plus the derivative of the first times the second. Ever how you want to do that, it's fine with me, but you're still going to get the exact same answer. We can fix this up a little bit and put these two numbers in front. 4 times 4 is 16, so this equals 16. 5x to the 4 plus 3x squared to the third times 4x minus 8 raised to the third, like that. Alright, so we took care of this. Alright, so now let's see, do we have anything else to multiply here? Well, we just have to bring the rest of this down. So plus 3, and just let everything ride like it is. Let's see, 5x to the fourth plus 3x squared. Okay, so let me just put the plus sign down here. I apologize for, okay, let's put it down here. So plus, now 3 times 5x to the fourth plus 3x squared. And do not forget that square up here. Alright, times 20 x cubed plus 6x times 4x minus 8 raised to the fourth. Okay. Alright, that's actually it right there. When you have two exponents like this and it's times, you're going to have something long and drawn out, so get ready. And you just have to be extra careful when you take these derivatives. Okay, barred that everything is done correctly. The first times the derivative of the second, plus the derivative of the first, yes, times the second. Okay. All right, and that's it. Okay. Let's look at something else. I'm going to flip the board over this time. If I have to erase, I will. We'll come back and erase again. But let's flip the board over. I love this board, I tell you. All right. Well, let's just, we're staying on black all the time. Let's do blue a little bit. All right. Now let's do something like this. Oh yeah, let's knock over some stuff first. Okay. Alright, so now let's say if, let's do this one. If, okay, f of x is equal to tangent to the 7, 5x. So we want to find f prime at x. Alright, so here we go. F prime at x equals. Okay, now really, this is a 7. This may be understood. It's not, maybe it is understood to be like that. Keep that in mind. If it is written like, it's not going to be written like that most of the time. It's just going to have that 7 just embedded right there. So understand that it's the same as that I just showed you. So now this is again the power rule. We've got to do that first. So 7. Nothing done with 7 here. We're going to raise this up to the 6th power though. And then this is 5x. Okay. So you have to take care of your power rule first. Okay. So make sure you understand that. You do the power rule first. Do nothing to tangent. Do nothing to your argument inside tangent, where that is. Now we keep going. Okay. There are no plus signs here. We just keep going. Now the derivative of tangent. We're not doing tangent. No, it's just tangent. Derivative of tangent is secant squared. So secant squared of 5x, nothing changes there. And then the derivative of 5x, which is just 5. Okay, that's it. And if you want to, 5 times 7 is 35. So 5 times 7 is 35. Tangent to the 6th, 5x, times secant squared, 5x, times 5. Oh, well, we already multiplied 5 times 7. Okay. And that's it right there. Okay. There it is. Okay. So this is the big thing. 7 and this, nothing doing here, nothing doing here. That's all you're doing. Make one move. In chess, you make one move at a time, not 2. Wish I could make 5 at one time, but in chess, but can't do that. One move at a time. Then this. One move. Not here yet. Then this here. Okay? Alright, that takes care of this problem. Alright, so, where's my, I'm trying to look for my eraser. Ah, there it is. Okay, that's a good problem. I like it. I like this problem. Alright, I want to do one that's like this, similar. we had x, we'll do g instead of f this time, is the cube root of sine to the 4x. Okay, and we want to find g prime of x. Alright, here we go. Well, we're going to rewrite g at x. Anytime there is a root involved, you rewrite it. Okay? Okay, so here we go. This is going to be sine 4x, and that's raised. Now this exponent here is 1, understood 1 here for all of this, and then, so this is actually to the 1/3. The power over the index. If we have the cube root of x, it's the power over the, like that. If you had the cube root of x squared, that's, okay, the power over the index, like that. Okay? Hopefully you understand where I'm coming from with that. Alright, so let's go erase this. That's the first thing that you need to do. That 1/3 could have been embedded right in here, just like that tangent to the 7th was. Alright, so now we're going to do the same thing, g prime at x. Alright, now 1/3, nothing doing here yet, sine of 4x. Now we need to reduce that by 1, so we got 1/3 minus 1, which is the same as 1/3 minus, we want to try to get something that's the same thing as 1. Well, 3/3 is equal to 1. I could have used 4/4, but I don't want to do that. I want to keep the same denominator here, so 3/3 is equal to 1. Alright, so 1 minus 3 is -2. Alright, there we go. That's to the -2/3 right there. Okay, that takes care of that. 1/3 minus 1 is -2/3. That makes sense because 1 is bigger than 1/3. Okay. Alright, now times, keep times, no pluses, times the derivative of sine is cosine. Now the derivative of 4x is just 4, and there you go. Well, 4 times 1/3 is 4/3, so 4/3, and I'm going to reserve putting this up here. Matter of fact, this is over. This is all, this is in the denominator. This needs to be in the denominator. Here's what we'll do. So 4, and I'm going to put cosine of, 4 times 1 is 4. Alright, cosine 4x, like that. Okay, and I probably don't need those parentheses if I don't need those parentheses really. Okay, 4 cosine 4x. This does not have a negative exponent, it has a positive exponent, understood to be 1. This has a negative exponent, so I'm going to bring this down with the 3. It's already, the 3 is in the denominator. I'm going to put this sine 4x to the positive 2/3. Now, let's do a little something here. Y to the 2/3. Y to the 2/3 is equal to the cube root of y squared. Remember, this is the exponent here, so I'm going to do that. So this equals 4 cosine of 4x over, 3 times the cube root of sine squared 4x. Now remember, I can put that 2 right there. Alright, that's pretty much it. That's the answer right there. Now, yeah, okay. Some people might expand cosine 4x and sine 4x. I'm not going to do that. Just let it be right there. Okay, again, this represents the slope of the tangent line, or what else? Instantaneous velocity. It could represent, well, any rate of change that we want. Okay, but anyway, there it is. Alright, so that is what we've been dealing with here. I don't know if I want to do one more or not. I do think this will suffice. I don't want to go any more. It can get more complicated, so I'm going to leave it at this. So just basically just understand you can, in these particular cases where you have some kind of nth root, you can rewrite this to a power here. The 1/3 could have went right here. Alright, but usually it does not matter. You can put the whole thing in parentheses. Don't just do this. That's wrong. You're saying 4x to the 1/3. You need the whole thing in parentheses here, like that. Okay, and then just remember, well, let's see, what 1 plus something is, it's 3/3, so 1 plus 2 is 3, but you got to have a negative here because you subtracted 1 from that. Okay, that is that. This again is KP, the Math G, signing off, and we hope that you have a really wonderful and blessed day. Thank you so much for tuning in.